what we're going to do is we're going to continue our talk around rate law that we had in class. And as discussed in class, all of the 5 factors that we've been talking about, surface area, concentration, catalyst, chemical nature, and temperature, all have an influence on the rate of the reaction. And it can all be mathematically linked as well. If we change one of those, the rate changes. But what we're going to do is we're going to be looking specifically at the relationship between the rate of reaction and the initial concentration of the reactants. And what we find is that the rate of reaction is proportional to the concentration of the reactants raised to some coefficient, which we'll call m and n. Now, m and n are orders of our reaction, and they have to be determined experimentally. Okay, they're not necessarily the coefficients from our balanced chemical equation. K is referred to as our rate law constant, and it has units, which is unique to each rate law. All of this has to be determined experimentally. Okay, and so what we have to do is we have to perform a series of experiments to obtain this. And there are a number of different ways that we can perform these experiments. One of the ways we can perform them is we just change the concentration of one reactant and we record how long it takes for a change to occur, or we measure the rate at which a product is formed. And then we can determine the rate in a graphical method with that. Another way is that we can set the initial concentrations of both my reactants, let the reaction run, and measure the rate of the products being formed, and then set up a second trial where we change the concentrations again. This would allow us to determine the rate of a reaction using what we call our 2-point method. Okay, and so here we have an example where we had set up 4 trials, and we have 3 reactants, A, B, and C, and we manipulated their concentrations in different trials. And we measured the rate of the formation of one of my products. And then we have a 5th trial for which we want to use our rate law to predict what the rate of the formation of D would be. Now, the first thing we always have to do when we're going to solve these is we have to write out our generic rate law equation. So all we do is we say the rate of reaction is equal to our rate law constant K times the concentration of each of the reactants raised to some power. And so in this case, I'll say A raised to the power of m, B raised to the power of n, and C raised to the power of p. You'll notice I skipped O because it looks like a 0. We don't want to create confusion. You can use X, Y, and Z, A, B, and C. I wouldn't use A, B, and C because that might confuse you and make you think it's from the balanced equation. But you can use any 3 variables to denote what the exponents are. Then our second thing that we have to do, and I will be looking for, is for you to substitute the values for each of the trials into the equation. So I have 4 trials where I know the rate and the concentrations for it. So therefore, I substituted the values in. I have changed the powers of 10 from there when I substituted them in so that they're all the same power of 10. This will just make for doing the math a bit easier when we move forward. You don't have to do this step. Now, I have all of my trials substituted in. And so what I'm going to do is I'm going to look at picking 2 trials where I keep the concentrations of everything except for one reactant the same. And this will allow me to determine the coefficient for that. So if I look at trial 1 and trial 2, the concentrations of A and C are the same for both of them, but the concentration of B changes. So therefore what I'm going to do is I'm going to take one of them and divide it by the other. It does not matter which trial you divide by which trial. What matters is you want to ensure that as many of the concentrations as possible are the same. Generally what we do is we have the trial with a higher rate be divided by the trial with the lower rate. And so here I'm going to take trial 2 because it has a higher rate of production of D and divided by trial 1. This allows me to cancel out all of the terms that are common in the top and the bottom. So I can cancel out my K's, my concentration of A, my concentration of C, and I'm left with my values here divided by my concentration of B in my two trials. I'll apply one of my log rules so that I can, or sorry, power rules so that I can change how my brackets are. Now I have my power outside the brackets. And then with the application of the log rules, I know that my value for n is 2. So now I know that the concentration of B is raised to the power of 2, or is to the second order. So now what I'm going to do is I'm going to look at doing 2 more of the trials. And now in this case, it's only possible to keep the concentration of one of them the same because the concentration of B is not consistent. But since I know the value of n, I can use it in determining the orders of M and P. So therefore, what I can do is I can apply my values, solve for M. And I'm sorry, this should be a superscript. I wrote it wrong. Okay, and so now I know my value of M. And since I know that M is 0, I don't have to include the concentration of A in any further calculations. But I'm going to take now a trial where I keep B the same. I only manipulate C. Yes, the concentration of A changes, but because I know the value of M to be 0, I get to reject it. And I get the value, the order due to P as being 1. So now I know my values of M, N, and P. And so I have my rate law. And as you can see, it's A to the concentration of 0, B to the power of 2, and C to the power of 1. So now what I can do is I can solve for So what I will do is I will pick one of my trials and I will substitute the values in. You'll notice I included units because if I don't include the units, I won't be able to get the units for K properly. And what I do is I solve for K with my units and I get my value for K. Now I know my rate law. I know my value of K. I know my orders in terms of B and C and A. So now what I can do is I can use this to determine the rate of my 5th trial. All I have to do is substitute those values in, and I get to the rate of the formation of D.